found something that was, in his words, cool, come in and talk about it. Well, I've been seeing recent happenings in second factor authentication that have me excited, and I want to share that excitement with you tonight. And my anticipation is, over the course of time, what we're discussing tonight, you will be sharing with others, because I think it has the potential to make significant changes in the way we do authentication across the web. Authentication is often perceived as three types of factors: something you know, something you have, or something that you are. Second factor authentication uses multiple factors, but they don't have to be multiple different types of factors. Because they're inexpensive, passwords have been our primary authentication factor. Passwords are adequate for a well-protected mainframe sitting in a closed environment on an isolated network. Does that use case correspond to the internet as we know it today? No, it does not. And so how well do passwords work on the internet? This tells you they're still inexpensive to implement, but costly when they're misused. The promise of single sign-on has only been partially successful and only within domains of constant security policy. The internet is just too diverse and disparate for single sign-on to be effective. What we have is different INA schemes used everywhere. Most of us have more passwords than we can remember, and if we do remember them all, typically their entropy is substandard. So if you're not already using a password manager, I encourage you to go out and get one. Password managers allow us to have unique, robust passwords for every website. And you only need to remember that single password for the password manager. LastPass is at the top of my list only because that's where it typically falls on evaluations of password managers. It does support multi-factor authentication, and it's one I'm familiar with. You need to remember that when you're using a password manager, it's no longer, passwords are no longer something that you know, they've become something that you have. And that means that the passwords and the second factors that you use to gain access to your password manager need to be robust. Send around some samples here that I will be discussing. One-time passwords are often employed as single factor supplementing the usual user ID password. A one-time password is most frequently a pseudo-random value associated with either a time or a sequence. So you use most of those, we mix them with a key, and out comes your one-time password. There are many one-time password implementations. You can have key fobs, you can have credit material, smart cards. They can be something like the Android, Google, or excuse me, not the Android, but the Google Authenticator on the Android phone, and USB tokens such as these that you are made by YubiKey. On the sheet that's going around, I provided the standard and the now. Being in hardware, those provide data at rest protection for the cryptographic mechanisms and for their secrets. When the relying party sends down a challenge, comes into the key, and a response is generated with the key and sent back to the relying party, or it's also known as the website. And the token continues to increment its count. What we're observing over time is that cost is coming down and user experience tends to get better for these. But one-time passwords improve security, but they don't work across the breadth of the web. They normally only secure a single domain. They can be defeated by man-in-the-middle attacks. And to be truly useful, they need to be some electronic form. The Fast Identity Online Alliance is an industry consortium launched in February of 2013 to address the lack of interoperability among strong authentication devices and the problems that users face creating and remembering multiple usernames and passwords. Here's one. The organizations shown here are the major participants in over 140 members of this alliance. FIDO released 2 specifications in December of last year. The Universal Authentication Framework and the Universal Second Factor. In the Universal Authentication Framework, the user registers their device to the online service by selecting a local authentication mechanism, such as swiping a finger, looking at a camera, entering a PIN, etc. And then once registered, the user simply repeats the local authentication action whenever they need to authenticate to the service. The user no longer necessarily needs to enter their password when authenticating from that device. So a second factor authentication scheme, if it's robust enough, can become the single primary factor. For FIDO registration, the user chooses an available FIDO authentication scheme that matches what the online service has in their acceptance policy. The user unlocks the FIDO authenticator using a fingerprint reader, a button on a second factor device, or securely entering a PIN. The user device creates a public-private key pair for the local device that's unique to the online service and to the user's account. So that's a lot of different public key pairs that get generated in the scheme. The public key is sent to the online service where it's bound to the associated user account. The red private key for that public-private key pair is typically encrypted and also sent up to the online service. And then any information about the biometrics is also sent there. In the login sequence, the relying party sends down a challenge down to the previously registered device. The user unlocks their authentication scheme, same one that they used at registration. The device's user account identifier is provided by the service, which will tell them which key slot to pull from. The device then sends back the encrypted response to the nonce that was sent from the relying party. That goes back, the site looks up, and authentication occurs. The universal second factor is a specific implementation of that UAF stack. It allows online services to augment the security of their existing password infrastructure by using a strong second factor for user logins. Put in your user ID and password like you did before, but it no longer needs to be a strong password. It can even be a 4-digit PIN. The service sends down the authentication nonce, and the response goes back. I'm sending around some examples of universal second factor compliant technology. Folks at YubiKey were kind enough to provide me some of these examples. Oops. This YubiKey token, which goes into your USB slot, you push the little button there in the center when you receive a challenge. That in single quantity is $18 on Amazon. This plug-up security key is $6 on Amazon. Both of them do the same function. One of them's just a little bit more rugged for the long term. This one does not have a button that you push, but you take it out, put it in every time you get a challenge. These Neo devices, which have the same form factors as the ones that went around earlier, are about $16 a piece. Big money, but they support not only the universal second factor. Go ahead. Okay, thanks. They also support the one-time password, and they also support near-field communication so that you can use them with a handheld. Google was the prime leader in the development of universal second factor, and so, strange enough, Chrome and Google already support that right now, coming out of moments. You cannot back up the universal second factor key. So if you go down this path, my recommendation is buy two, and one of them, and all of the websites typically support like about 5 different tokens simultaneously that you can bind to. Make one of them your primary, one of them your secondary, and keep your secondary in a safe place. About the same time that FIDO was started up, Steve Gibson, developer of SpinRite and host of Security Now, independently began developing his Squirrel software architecture for authenticated login that would work across the web. Like FIDO, Squirrel uses a challenge and response with the real-time party. In Squirrel, the response, or challenge I should say, is embedded in a QR code. That's the part of the name there. And this can be processed on either smartphone or on your desktop. The architecture for this has been published and released in the public domain, and Steve and interested volunteers are writing client-server implementations of the architecture. The first reference implementations are expected to be deployed this month. And a quick comparison of the two. Universal second factor provides authentication. Squirrel can also support identity. Universal second factor is focused on the device, whereas Squirrel has better binding to the individual user identity. Your Squirrel identity is intended to be able to be maintained over your lifetime. Both of them use strong elliptic curve public key encryption. The public key is unique, each relying party, and that's what's contained on the website. What's sent to the website is effectively just bits. It's good enough for their authentication. The hacker gets in, it's useless to a hacker. It's no use on any other website. So there's tremendous benefits that accrue from this type of technology. Universal second factor is very much dependent upon the browser. Squirrel uses right now a browser and an extension, but it doesn't necessarily need to be tied to the browser. The second factor is hardware-based. Squirrel is software-based. If you're interested in further information, go to these sites. They will provide you all of the specifications, documentation, and point you to implementations of these. I encourage you, as time progresses, to go buy either one of these tokens or to implement Squirrel on your PC. Because I see that there are tremendous benefits by being able to get yourself off of passwords, and as we look at the rest of the web infrastructure, a lot of benefits that can improve by having passwords removed from our infrastructure. That is all. Yeah.
Any questions?
What about places that have like USB policies that you can't plug into?
That's why I said try this at home. Because I'm one of those places. Yes, sir.
So apparently, once you're arrested, you have to, you can give your fingerprint. That's something that they require you to free because they're already taking fingerprints of your hands. Would the same also be true for biometric devices that are solely unlocked for your fingerprint? Have you heard about that?
That are, in terms of authentication devices that are solely unlocked from your fingerprint?
Right, just a single factor biometric for fingerprints. Is that something that you would have to give to someone for?
No. In terms of basically what this is providing is a very low-cost implementation of cryptographic logo. If you look at the either of the universal second factor products, all you have to do is make an acknowledgement that somebody sent you a request for authentication. On the card-based one, it was, I got a request, I take it out, I put it back in. On the other ones, you basically touch either the center pin or the tip of it so that it says, okay, some human did something, and that's the only user experience action that's involved. And it's basically relying upon that cryptographic logon associated with that device.